Find the limit as n approaches infinity of log 2 plus 3 to the n divided by 2n. And we're given a hint that log of 2 plus 3 to the n is equal to log 3 to the n plus log of 2 plus 3 to the n divided by 3 to the n. Okay. So limit as n approaches infinity of log 2 plus 3 to the n divided by 2n. I wonder if the answer is just going to be 3 over 2. But let's work it out. So the hint is that log of 2 plus 3 to the n is equal to log 3 to the n plus log 2 plus 3 to the n divided by 3 to the n. And that's just using laws of logarithms, right? We have a logarithm of something divided by something else, so we can write that as a difference of logarithms. And log of 3n taken as a difference would cancel that. So I think now what we can do in the original limit, I'll replace the numerator with what's given in the hint. So we've got that. In the first term, this is of course just, oh sorry, it's not going to be 3 over 2, it's going to be log 3 over 2. Anyway, that's fine. So this is n log 3 divided by 2n plus, I'm gonna write this as a sum of limits. I suppose technically we would have to check that at the end of all this the individual limits make sense, but that will be the case here. Okay, so this first limit, n cancels in the numerator and denominator, so I'm left with log 3 divided by 2. And here, I'll keep this as a limit for now, but in the numerator, this becomes log of 2 over 3 to the n plus 1 divided by 2n. So for every value of n, this is of course strictly greater than 1. So this is a positive number, but it's decreasing with respect to n. So this whole thing is a decreasing sequence of positive numbers, and this is, well, linear with respect to n. So it's they're all positive, they're decreasing, meaning that at some point they're always going to be less than some constant, some positive constant, and so this limit is in fact just simply going to be equal to 0. So that limit is gone. That's equal to 0. So at the end of this, I get log of 3 divided by 2. That's the value of the original limit. Yeah, it should have been somewhat obvious from the beginning, given that, logarithms and exponentials kind of, they're inverses of each other. And for extremely large values of n, this 2 is going to be insignificant, which is kind of what is shown here. The small shift within here is insignificant with respect to the overall growth of things. And then this logarithm is basically undoing the exponentiation there, but you just have a constant of log 3. Yeah, nice little problem. Thanks for watching.